Hey, welcome back. Chapter 3, this is section 3.2, States and Properties of Matter. Some important information in here. A lot of the information, though, honestly, you've seen and you've had before, so this will be a short one. The biggest, most important idea in this section is right here. The three states of matter differ because of attractive forces between the particles. So what we're saying here is that here's one particle of matter, could be whatever. Here's another particle of matter. Again, it could be whatever. The force of attraction between these two particles, that's what defines in the macro structure. So we have literally billions upon billions of these particles, and they all have these attractive forces. But it's the attractive force between those particles that defines whether it's a solid, liquid, or gas. And then the attractive forces also determines sort of the properties that you often associate with the solid, liquid, and gas. Okay, so really, really strong forces of attraction. So let me just jot this down over here. Strong forces of attraction. That's going to be a solid. As we weaken those, so if we have weakened, not broken, but weakened forces of attraction, and now we're talking about a liquid. So now in a solid, they're really rigid. Those forces of attraction are so strong that really all those molecules can do is just vibrate in place. Where if we weaken them a little bit, now those molecules can slip and slide all over each other, and that's a liquid. And then if we completely break those intermolecular forces, so break those forces of attraction, now we're talking about a gas. So a gas, we really think of a gas as the particles don't really much interact with each other. And again, the forces of attraction is what defines what you typically think of for the states of matter, which is, a solid has a defined volume, a liquid will take the shape of its container, a gas will fill the entire container, and these are all attributes because of the forces of attraction. Now, we'll talk very, very specifically about the forces of attraction in a subsequent chapter. I think it's 11, don't quote me on that. So for now, just know that it's the forces of attraction between the particles that really defines whether it's a solid, liquid, or gas. So because that's what we're going to look at. We want to look at on the molecular level. Okay? All right. And of course know this general stuff, but that's stuff that you should know anyway. And we can describe matter. And the ways that we can describe matter is we can either use physical properties or we can use chemical properties. Now, physical properties are, it doesn't matter how much is there, they're always going to have the same characteristic. Right? So some good examples here would be a boiling point, melting point, color. So for instance, here is, let's say, 10 grams of water. 10 grams. Now, that 10 grams of water has a boiling point of 100 degrees Celsius at 1 atmospheric pressure. Right? Now, if I have, let's say, 5,000 grams of water, it still has a boiling point of 100 degrees Celsius. Okay, so that's a physical characteristic. It doesn't change. The melting point, let's say paraffin, which you're going to deal with this year, paraffin wax, has a melting point of around 60 degrees Celsius, give or take. No matter how much of that paraffin wax I have, it's going to melt at 60 degrees Celsius. So again, that's a physical property. Now, physical properties take advantage of what are called physical changes. And a physical change is where you're changing just from one state to another. So you're going from solid to liquid, liquid to gas, gas to liquid, liquid to solid, solid to gas, gas to solid. Okay, so those are going to be the physical changes. And the key to a physical change is, did the substance change? Do we have a brand new substance? If we had a brand new substance, it's not a physical change, it's a chemical change. But if the substance is still the same, then it's just a physical change. So the example that I give is just ice melting. When ice melts, it goes from solid to liquid, but it's still H2O. No difference. Now, the one that students always make a mistake on is dissolving a solid in a solvent. So, for example, salt dissolving in water. Everyone always thinks that's a chemical change, but it's not. That's a physical change. We can easily get that salt back. We can easily get that water back. Right? So if I can easily change it back, it's a physical change as well. Now, physical property is one way to describe matter. Another way to describe matter, chemical properties. Now, this is going to describe the ability of a substance to undergo a change. A lot of times, not all the time, but most times, they're going to react with another substance. So mostly via a reaction, RXN, with another substance. Okay, so for example, sodium. Sodium will react with oxygen to form sodium oxide. Okay, this fine white layer that's on top of it. Oxygen's a gas, right? Sodium oxide's a solid. And we cannot easily change that back to sodium, okay, which is how we know it's a chemical change. But we also have a brand new substance, sodium oxide. Sodium oxide wasn't there before, so it's a brand new substance. So in all of these examples, tarnishing silver, that's silver reacting with something else. Wood, that's actually the wood reacting with something else. Caramelizing sugar, now this is the one instance where it's just sugar and heat. But then forming rust, this is reacting with something else. Okay. So again, just to summarize here, a physical property, you're not changing the substance. It starts out as one substance, it ends as that same substance. Chemical property, we are creating a brand new substance, and we can't easily change it back. Think about ice melting, we can easily change that back into ice. Okay. Think about silver being tarnished, we can't easily change that silver back. That silver sulfide now, because that's what tarnish is. There you go.